Compositors arrange individual metal-type characters into text columns, assembling words letter by letter to create the pages that will carry news and information to thousands of readers. The massive rotary press receives curved stereotype plates mounted on rotating cylinders, spinning at tremendous speed while paper feeds continuously through printing mechanisms. Ink rollers distribute black printing ink across the stereotype surfaces, transferring text and images onto rapidly moving paper with precision that enables reading the smallest type. Printed newspapers emerge from folding mechanisms already creased and ready for bundling. Automated production replacing the hand folding that limited earlier printing operations. This is just part of the systematic process transforming blank paper into printed newspapers inside this 1870s steam-powered factory. Before we continue with the complete process, if you could leave a like and subscribe to the channel, it would really help this project continue bringing historical industrial content. Thank you for your attention. Now back to the video. Blank paper arrives at the printing factory in large rolls, manufactured specifically for newspaper production with characteristics enabling rapid printing and economic production of daily publications distributed to growing urban populations. These paper rolls represent the foundation of mass communication, as the 1870s newspaper industry consumes enormous quantities of newsprint to meet demand from readers expecting daily coverage of local events, national politics, international news, commercial information, and diverse content serving an increasingly literate society. Workers move the heavy paper rolls into storage areas near the printing presses, organizing inventory to ensure continuous production flow as presses consume material at remarkable rates during production runs. The paper quality balances cost against performance requirements, with newspaper stock intentionally designed for temporary use rather than permanent preservation, accepting lower durability and faster aging in exchange for the low prices enabling affordable daily publication. The composing room represents the factory's intellectual center, where skilled compositors transform written articles into physical type arrangements that will transfer ink to paper during printing. These workers maintain extensive type cases containing thousands of individual metal characters, organized systematically to enable rapid selection during composition work that converts manuscript pages into printed forms. Compositors read copy while selecting individual letters, spaces, and punctuation marks, assembling them into words and lines using composing sticks that hold type during arrangement. This letter-by-letter assembly requires exceptional accuracy as errors multiply across thousands of printed copies, making careful composition essential for maintaining newspaper credibility and reader satisfaction. The metal type, cast from lead alloy, displays raised letter forms that will receive ink and transfer impressions to paper, with each character precisely sized to create even lines and consistent spacing throughout printed pages. As compositors complete text columns, workers transfer the assembled type to imposing tables, where entire pages are built by combining multiple columns with headlines, advertisements, and any illustrations or decorative elements included in the publication. This page assembly creates the forme, a complete arrangement locked into iron frames called chases that hold everything rigidly during the stereotyping and printing processes. The forme assembly requires careful attention to spacing and alignment, ensuring columns appear properly positioned and text aligns correctly when pages are printed and folded into finished newspapers. Workers check the assembled forms carefully, reading proof copies printed from the type to catch errors before production begins, as corrections become increasingly difficult and expensive once stereotyping proceeds. The stereotyping process represents crucial 1870s technology that preserves type arrangements while creating durable curved printing plates suited to rotary press cylinders. Workers press specially prepared papier-mâché material called flong against the assembled type former, creating a matrix that captures every detail of the raised letter surfaces in a flexible sheet. This flong matrix is dried and then used as a mold for casting the actual stereotype plate, with molten metal poured into the matrix and cooled to create a solid duplicate of the original type arrangement. The resulting stereotype plate displays all the text and images from the form in raised relief, suitable for inking and printing. But unlike the fragile individual type pieces, The stereotype provides a durable one-piece printing surface that can produce thousands of impressions without damage. For rotary press use, workers curve the flat stereotype plates to match the cylinder circumferences, creating the cylindrical printing surfaces that enable continuous high-speed operation, distinguishing rotary presses from slower flatbed designs. This curving requires precision to prevent distortion that would create uneven printing or mechanical problems during press operation. Multiple stereotype plates may be prepared from a single form, enabling simultaneous printing on multiple presses or preserving plates for reprinting popular content, demonstrating how stereotyping separates the labor-intensive composition work from the actual printing production. If you could leave a like and subscribe, it would help keep this channel active with quality historical content. Thank you for your attention. Now continuing with the process. Ink preparation ensures proper consistency and coverage for high-speed newspaper printing, with workers mixing black pigment and oil-based vehicles to create fluid ink that transfers cleanly while drying rapidly enough to prevent smudging as printed sheets stack and fold. The ink quality directly affects print clarity and production efficiency, as improperly formulated ink either fails to transfer completely, creating light or missing text, or remains too wet, causing smudging and offsetting that ruins printed copies. Workers test ink consistency frequently, adjusting formulations to maintain optimal performance as temperature and humidity conditions change throughout production runs. Large ink fountains on the printing presses hold substantial ink quantities, feeding the distribution rollers that will spread ink across the stereotype surfaces during operation. The rotary press dominates the printing floor, its massive cast iron frame and rotating cylinders representing the technological advancement that enables newspapers to reach mass audiences through production speeds impossible with earlier printing methods. Steam power drives the press through heavy gearing and line shafts, rotating the large cylinders at speeds that can produce thousands of impressions per hour when operating at full capacity. The press contains multiple cylinder pairs, with one cylinder carrying the curved stereotype plate while its opposing cylinder provides the impression pressure forcing paper against the inked stereotype surface. Paper feeds from the large supply rolls through tensioning and guiding systems that maintain proper alignment as it travels through the printing mechanisms at remarkable speed. As the stereotype cylinder rotates, ink rollers contact its surface, distributing fresh ink across the raised type and image areas, while avoiding the recessed spaces that should remain white on printed sheets. This selective inking relies on the relief printing principle, where only raised surfaces receive ink and transfer impressions to paper, creating the contrast between printed text and blank paper that enables reading. The paper web travels between the stereotype and impression cylinders, experiencing brief but substantial pressure as it passes through the nip point where cylinders nearly touch. This pressure forces paper fibers against the inked stereotype surface, transferring ink in patterns matching the raised type arrangement and creating the printed image appearing on the paper as it emerges from the cylinders. The rotary press's continuous operation creates dramatic production advantages over flatbed presses, requiring repeated stops for inking and paper positioning, as the rotating cylinders maintain constant motion while paper feeds steadily through the machine. Workers monitor the press carefully, watching for paper breaks, misalignment, or ink problems that require immediate correction to prevent waste and maintain production schedules. The press produces a continuous stream of printed paper emerging from the printing cylinders, displaying text and images transferred from the stereotype plates in rapid succession as the web moves through the machine. Multiple printing units may be arranged in sequence, enabling simultaneous printing on both sides of the paper web, or adding additional content through successive impression operations. This multi-unit configuration maximizes production efficiency, allowing complete newspaper printing in a single pass through the press, rather than requiring separate runs for different pages or sides. The coordination between printing units requires precise registration, ensuring images and text align properly when multiple impressions combine to create finished pages. The printed paper web proceeds to folding mechanisms that crease and fold the continuous sheet, into individual newspaper copies, transforming the flat printed web into the familiar folded format readers expect when purchasing their daily papers. These folding devices operate automatically at high speed, creating precise creases and folds, synchronized with the press's rotation to produce properly formed newspapers emerging ready for cutting and bundling. The folding process represents significant automation compared to hand folding that previously limited newspaper production, as mechanical folders maintain consistent quality while operating at speeds matching the rotary press's output. Cutting mechanisms trim the folded newspapers to final size, removing excess paper and creating clean edges on the finished products. These cutters operate in coordination with the folding equipment, severing individual newspaper copies from the continuous web at precisely timed intervals that match the folding pattern. The cut newspapers accumulate on delivery tables, where workers gather them into bundles for distribution, checking quality and ensuring proper folding and cutting before packaging. Workers bundle the finished newspapers using twine or wire, creating standardized packages facilitating handling during distribution to newsstands, delivery routes, and other sales locations throughout the city. Each bundle receives labeling indicating quantity, edition, and sometimes destination information, helping distributors manage the complex logistics of delivering thousands of copies to numerous locations on tight schedules. The bundling area operates continuously during production runs, with workers maintaining rapid pace, necessary to keep up with the press's output while ensuring secure packaging preventing damage during transport. Quality inspection occurs throughout production, with workers examining printed copies for clarity, proper ink coverage, correct alignment, and freedom from defects that would make newspapers unsaleable or damage the publication's reputation. Inspectors check early copies from production runs particularly carefully, catching problems before substantial quantities of defective newspapers accumulate. Any significant quality issues require immediate press adjustment or correction, as the high-speed production means defects can affect thousands of copies in minutes if not addressed quickly. The printing factory operates on strict schedules driven by publication deadlines, as newspapers must reach readers on specific dates to maintain relevance and meet subscriber expectations. This time pressure creates intense operational demands, with compositors, stereotypers, press operators, and other workers coordinating activities to ensure timely completion despite the complex sequence of operations required for newspaper production. The factory may operate multiple shifts, particularly for daily publications requiring fresh content and rapid turnaround between editions. Inside steam-powered printing factories like this, mechanical systems and skilled labor combine to produce newspapers that inform and connect urban populations on unprecedented scales. The machinery continues operating, prepared to receive new manuscript copy and repeat the composition, stereotyping and printing cycles, creating the publications that serve as primary information sources for millions of readers. Steam power enables the sustained high-speed operation necessary for mass newspaper production, driving rotary presses at speeds that hand-powered equipment could never achieve, while maintaining the force required for clear impression transfer. Workers combine specialized skills in composition, stereotyping, press operation, and finishing tasks, maintaining quality while achieving production volumes that make daily newspapers economically viable and widely accessible throughout society. Did you know that by the 1870s, the fastest rotary presses could print over 20,000 newspapers per hour? If you enjoyed learning about newspaper printing from the 1870s, please subscribe to the channel, leave a like, and comment about what surprised you most. Your support helps us continue bringing historical industrial content. Thank you for watching. See you in the next video.